Uh, Hello, everyone. This video is about revising the DC electricity topic of year 12 physics. So mainly in this topic, I will be focusing on Ohm's law and then conservation of energy in an electric circuit, which is when we talk about the power of the battery and the power used up by different resistors in the circuit. So let's look at the Ohm's law, which is the relationship between the current, voltage, and resistors. Current is the amount of charge that passes through a point in 1 second, and this ammeter will be measuring the current that is passing through the resistor and goes back into the battery. This voltmeter measures the voltage or the energy per coulomb that is used up by a resistor. A resistor changes electrical energy into heat energy. If it was the lamp, it will change electrical energy into light energy. If a voltmeter is used to measure the voltage of the battery, then it uses or it measures the voltage provided by the battery. So now we are looking at the relationship between the current, voltage, and resistance. If voltage is kept constant, so there is only one resistor, so voltage across the resistor will be same as the battery voltage. So if voltage is, if resistance is kept constant and voltage is increased, then the current in the circuit will increase, or we say that current is directly proportional to the voltage across the resistor. However, if the voltage is kept constant and the resistance of the resistor is changed, then by decreasing the resistance, current will increase, or by increasing the resistance, current will decrease, or we say that current is inversely proportional to the resistance. And this one, so we can see over here that if voltage is increased, current will increase. And if voltage is kept constant, then by increasing the resistance, current will have to decrease. So the voltage remains constant. So that's the relationship between voltage, current, and resistance. We can also write it I equals V over R. Now here, if a graph of voltage against current through the resistor is drawn, it comes out a straight line, and gradient of the graph represents the resistance of the resistor. So that's the Ohm's law. Now let's look at the energy in a circuit, and I will still use this same diagram. So this battery is providing electrical potential energy, and this resistor is changing that electrical potential energy into heat energy. So energy used up by this resistor is same as the energy provided by the battery. If there were 2 or 3 resistors in the circuit, it will still be the same. That energy used up by all the resistors will be equal to the energy provided by the battery, because that's the law of conservation of energy. We're assuming that none of the energy is lost during the transmission or transfer of the energy. So what is power? Power is the amount of energy supplied by the battery in 1 second. And power measures the brightness of a lamp or the heat produced by a resistor. So a 60-watt lamp will use up 60 joule of energy every second, where a 20-watt lamp will be dimmer than a 60-watt lamp because it uses only 20 joule of energy. So in general, what we are saying is that power, or the power rating that quite often written on different, your TV set or your electric stove or your light bulbs. And what it means is how much energy is used up by that particular lamp or a resistor in 1 second. In case of a resistor, it will be the measure of the heat produced, whereas in case of lamp, it's the measure of the brightness. Now, power depends on, so in this circuit, if there is bigger voltage, then it will be, this resistor will be using up or producing more heat. Or if current is larger, then it will be producing more heat. So power depends on the voltage and it depends on the current. What is the total energy use? That will be power times time. Now these are the two formulas that will be provided in this one, but you can figure out. So if we combine Ohm's law, so for example, in this equation, if we write down that V is equal to I times R, we get I squared times R. Or in the same equation, if we replace I with V over R, then we get this equation, but these equations are not provided. And units for power is obviously joule per second, or it is called watts, whereas unit for energy is joule. Now we will look at one example to explain all these one. So let's say circuit given will be something like that one. An 18-volt battery, there are 3 resistors, 2 ohm, 6 ohm, and 12 ohm. So first of all, we need to figure out what resistors are in series and which of the resistors are in parallel. So current comes out from here, positive of the battery. Here it divides into these 2 branches. That means these 2 are in parallel with one another. And then current joins back here, and then it goes through this one and 2 ohm resistor and back into the battery. So first of all, to make it look a little bit more simpler, what I've done is I have pushed this one because these 2 are in parallel and this one is in series with these 2 together. I've drawn this 2 ohm resistor there. So nothing has changed except that it makes it more clear that these 2 are in parallel and together they're in series with that one. Now, questions that could be asked is that which resistor has the most current passing through it? So obviously this resistor is in series with the battery, we can see that. So it will have the most current passing through the battery, passing through it. Whereas current, that 3 amp current, if 3 amp is going into the battery, it will be 3 amp coming and then it will be dividing. This one will have more current because it's a smaller resistance, and this one will have less current because it is a bigger resistor. So 3 amp will divide, just roughly we can say it will be 2 amps through there and it will be 1 amp through there. So question can be asked, which resistor has the least current passing through it? So it will be this one, 12, bigger resistor will have less current. Another question that will be quite often asked is calculate the voltages across different resistors, because finally they will ask you to calculate the power of each of every resistor or how much heat energy is produced every second. So this one, the voltage across the voltage is I times R. So this one will be 2 times 3. So that will be 6 volts across here. So now remember, in a circuit, voltage provided by a battery is shared by the resistors in a circuit. So if this one is using 6, that means these 2 together, they will be using 12. So 18 volt is the gain of electrical or energy supplied per second, gain of electrical potential energy. And so that is 18. This one is using up 6. So that means 12 volts are left for this parallel combination. Now we know that in parallel voltage is same. So both of these one will have 12 volts. So 12 volts across here and 12 volts across here. Again, if we have to calculate the current, we have already done initially that it divides in an inverse ratio of the resistance. But now we know that there's a 12 volts here, 12 volts here. So current is voltage divided by resistance. So 12 divided by 6 gives you 2, and 12 divided by 12 gives you 1. So 2 amp goes through there and 1 amp goes through there. Now, another question that would be asked is, which of these 3 resistors is producing the most heat energy every second? Or in other words, power of which resistor is most? Now, remember, this battery, power of this battery, if we have to calculate the power of this battery, that is voltage times current. So it is 18 times 3 is 54. That was the first question, 54 watts. Now, so this battery is providing 54 watts. So all these three together will be using 54 watts of energy every second. But to calculate these one, what we will do is we will simply, we already know the voltage and current values. So 6 ohm, so 2 ohm resistor will have a power of voltage times current. So voltage was 6 times 3 is 18 watts for 2 ohm resistor using same formula. This is the 6 ohm resistor. So their voltage is 12 for both of these one because they were in parallel. Current was 2, so gives you 24 watts. And this one is 12 times 1, which gives you 12 watts. So obviously, this resistor 6 ohm is using the most energy or producing the most heat energy. That is this one. Altogether, if we add all those three values that we've just calculated, that will be equal to the energy or the power provided by the battery. That will be 54 watts. So that's all for this DC electricity. These are the two main things, the power calculation and using Ohm's law. So thanks for watching this video. So bye for now.